In this particular scene, we can see Walter White and Jesse Pinkman, in which they're stranded in the desert and they're trying to figure out how to get out of there. To do that, they decide to come up with a homemade voltaic cell and see if they can jumpstart their RV. So for this particular video, then we're going to answer the following questions. Given 6 voltaic cells, can we produce enough voltage? And also, can we produce enough current to jumpstart a dead battery? Walter White mentioned that to create this voltaic cell, he used a salt bridge and electrolyte, the potassium hydroxide, as the anode, the zinc, as the cathode, a mercury oxide, and he also used copper wire as the conductor from the voltaic cell to the dead car battery. Well, to begin, we have to define what a battery is. A battery, by definition, is a group of voltaic cells. So in this case, Walter decided to create 6 voltaic cells by using the materials we just mentioned to see if we can jumpstart a dead battery.
This is a basic diagram of Walter's voltaic cell. A voltaic cell produces electrical work by the usage of an oxidation-reduction reaction. The transference of electrons from the anode to the cathode is what provides this electrical work. These electrons are not to scale. The electrons go from the anode to the cathode, and this transference of electrons provides electrical work to what the voltaic cell is attached to. The anode component of the cell houses the oxidation reaction, which separates 2 electrons from solid zinc to produce zinc 2 plus ions. The electrons then travel along the conductor to the cathode, where the electrons cause H2 plus to become liquid mercury. The transference of electrons causes a negative charge buildup in the cathode, and the formation of zinc 2 plus causes a positive charge buildup in the anode. And the salt bridge in the middle provides anions or cations to balance the difference in charge.
To put all of this into numbers, let's look at the half reactions. This is the half reaction of the mercury, which is the cathode, and this is the half reaction of the zinc, which is the anode. Once we combine 2 of these equations, we get the spontaneous oxidation reduction reaction. That it looks more or less like this. Now, to put the numbers, we have to follow the following formula, which is the E potential cell, which is the potential of the cathode minus the potential of the anode. We plug in the numbers. This is for mercury and this is for zinc. And once we plug in the numbers, we're able to find out that for one cell is 1.55 volts. Okay, so the following assumptions are what we follow for the calculations. We assume standard conditions. Given this, can Walt produce enough voltage to start a dead battery? Well, Walt was able to produce 1.55 volts for one cell, and that gives us a total of 9.30 volts. A regular battery requires at least 12 volts to jumpstart. So the answer is no. To actually produce a required voltage, we will need 10 cells. So we decided to also include a physics section. Why is that? Because to jumpstart a dead battery, we not only need voltage. So we went around and asked our physics professors, which is Brian Shotwell and Dr. Whitman, to see what else do we need. It turns out we also need to calculate the current. And also Walter mentions this on the video, and he was concerned if we were able to produce enough current. So what about current? Since we already have a voltage, we can calculate current by using the VIR or VIR equation, which is voltage equals to current times resistance. We already have the voltage, so now we need to find these two. However, we need yet another equation just to find resistance. Resistance comes from the copper wire. The components that we need to calculate resistance is rho, which is the resistivity of the conducting material, which is the copper wire that he used, L, the length of the conductor, which we decided to be 2 meters since we thought that we needed some distance between the cells and the actual battery all the way to the RB. And A, which is the cross-sectional area of the copper wire. By cross-sectional, it means that you take the wire, you cut it, and then you have a surface area that is in form of a circle. As we plug in the numbers, we find out that the resistance of this particular subject is 0.15 ohms. Once we have the resistance, we can go ahead and move this equation around to calculate current. And we have that now the current is equal to voltage divided by resistance. And once we do that math, we came to the conclusion that it is 62 amps what we can get from the whole full set of the 6 voltaic cells that Walter comes up with. So with those numbers in mind, can we answer the question, can Walt produce enough current? And the answer is no, he can't. We will need at least 400 amps to be able to jumpstart a dead battery. If we do the math for the 6 voltaic cells that he has, to actually produce required current, we have 39. And we actually have 6.
Good.
So in conclusion, can you actually jumpstart an RB battery with Walt's battery? No, you can't. The end.